This is Geometry, Semester 2. It's the unit on conics, number 7, and it's the Fibonacci Spiral practice. It's lesson number 5. It's on creatormath.com under the Geometry tab. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So with that, I am going to go straight to the notes on this one. So let's back up here just to orient where we are. Let's go back to the home page. This is creatormath.com, or you might have to type in creatormath.weebly.com when you search it in Google. Sometimes it needs this to find it. Here we are going to the Geometry tab. That's where all the notes are, and the units and the lessons. We're going to pass by the vocabulary, and we're going to go straight to the table of contents. This goes on pages 2 through 6 of your composition book. Make sure you're in semester 2, which this lesson is from. Copy all this in. We're going to go past all these units, conditional probability, angles and circles, surface area, and we're down to conics. Conics has 5 lessons within it, so this is the unit on conics. It has 5 lessons. We're on lesson number 5, which is Fibonacci Spiral. At this writing, it goes on pages 135, 136. Please don't look at this on this video, but go back and find the actual pages for the time you're doing it. By the time you watch this video, it could be different, right? Click Notes. This is what we will look at to put on those pages of the comp book, and this is what you will use to help solve these problems. So, conics number 5, Fibonacci Spiral. Here's the associated standard. The essential question: given a sequence of numbers which add to equal the third, how can we generalize the sequence? So it's kind of an interesting way to put it. Fibonacci sequence: 1, 1, 2, 3, 5, 8, 13, 21. Okay? That's the beginning, dot, 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 right? It continues on in this pattern. What's the pattern? Well, starting with a 1, 1, the third value is 2. How do we get 2? We add 1 plus 1. We got 2. So let's move to 3. How do we get 3? We add the 2 prior numbers, right? So 2 plus 1 is 3. Go to this one, and we add the 2 prior numbers. 2 plus 3 is 5. Go to this number, 8, and it's going to add the 2 prior numbers. 3 plus 5, go to 13, it adds the 2 prior numbers. 5 plus 8, go to 21, it adds the 2 prior numbers, etc. It continues on forever. So notice the difference in the values here: 2, 3, 5, 8, 13. That's the difference between the terms. This is the Fibonacci sequence. Now, there's also something called the golden spiral, right? The golden spiral uses rectangles, or rather squares, I'm sorry you guys, squares, 3 by 3, 2 by 2, 1 by 1, 4 by 4, 5 by 5, 6 by 6, 7 by 7, etc. The next one would be 8 by 8, 9 by 9, etc. The Fibonacci spiral versus the golden spiral. The two are technically different, but approximate each other as they get larger. Recitals: given a sequence of numbers starting with 1, 1, the next term is 2, and the next term is 3, and the next term is 5, and the next pair, because each pair adds to equal the next number. Vocabulary: Fibonacci sequence, the Fibonacci spiral. One is the sequence of numbers, the other is the spiral based on squares. Vocabulary: golden spiral. A spiral based on square areas, the Fibonacci sequence and the golden spiral, approximate each other as they get larger. Sequence: a set of numbers with a relationship to each other. So they give us some examples here, basically playing with these two ideas, and probably the most awesome thing that we're astounded by is sort of the approximation of this idea in nature. So let's see what kind of problems they give us. I don't expect them to be too difficult. The Fibonacci sequence is created by adding the prior 2 numbers to create the third. Which of the following is the sequence? It's this one here, the one we've been going over in the notes. And you got to start with these 2, because those are the 2 that add to be 2. Then these 2 add to be 3. Then these 2 add to be 5. Then these 2 add to be 8. Okay, so let's see what else. They want to kind of challenge us a little. Is a golden spiral and a Fibonacci spiral the same thing? No. But as Fibonacci spiral gets bigger and bigger, a Fibonacci spiral gets bigger and bigger, it more closely approximates the golden spiral. So that's cool. Neither is perfect in nature, but because they approximate each other, we start to apply it to different things. The following example of Fibonacci spiral / golden spiral is what form? So this is just a simple task, and I urge you to maybe Google Fibonacci Spiral or Golden Spiral and see all the examples that they put up for you. These are just a few. This is a rose. And it's amazing that if you take this golden spiral and you just place it over top of any number of things, you can take any number of photographs and start to move this spiral around, and you'll start to look at it and go, wow, that looks like it could really fit right there. Does it totally fit? I don't know, but it does seem to recur on a regular basis in nature. All right. The following is an example of the Fibonacci spiral / golden spiral. In what form? A sunflower. And it's in there somewhere. I don't know if I could draw it so good, but just look at the ones where they've laid it on top. The following is an example of a Fibonacci spiral / golden spiral. In what form? This is the Nautilus Shell, the famous Nautilus Shell. It starts out, and if you lay down your squares on there, this cool shape emerges, right? So amazing to us because we start to just see it repeating everywhere. And then you take it and just start laying it over top of things. Here's a cactus, and you can see it buried in there, the way this thing starts to spiral out like this, right? It has to keep getting bigger as it goes around that circle. And this one's a little harder to see. Just go online and Google it, and you can see some better examples maybe than this. But here they're just laying out this shape on top of a face, right? And showing how, hey, this kind of seems to coordinate in all different sort of places, almost as if we've been designed with this spiral in mind, or nature has designed us with this spiral in mind. However you want to look at it, I'm okay with. It's just a fascinating thing for you to study, and that's one of the things we try to do in math, is illustrate how this is applicable and why it's so cool to us, right? Here's a cat. These are cats laying on the floor, right? Look at that. It starts to approximate the cat's tail right here. I can't see it. The cat's tail's right there. Here's another one. Look at that. Starts out somewhere here. And it's not really fair in a way. If you just take this spiral and lay it over top of things, you're going to see it a lot. I don't know whether it's actually happening or it is happening, right? This is a cat. So this is kind of just an illustration of some of those. A very fun thing for us to think about and start to look for. And if you ever become a designer, which I hope a lot of you do, that's the point of creator math, right? As a designer, I want you to keep this spiral and this sequence of numbers in mind, and see if you can apply it in your designs. You might design some of the most fascinating whatever that the world has ever seen, because you're just sticking to a pattern that somehow has repeated so much in our design. All right, let's see what else. Oh, one more. It's another cat. Is that a cat? I can't tell if it's a cat. Might be a dog. Might be a small dog. Oh, it's a cat. All right. That's enough for that. Let's see. Go line this up, right? You're on Geometry Semester 2. It's the unit on conics, and it is the lesson on Fibonacci Spiral. It's number 5 lesson out of number 7 unit, and it's on creatormath.com under the Geometry tab.